Hello, audible?
Yes, sir.
Okay. So let us see. This question is a new pattern. It was not asked, but let us try discuss. Maybe they asked. Okay. So you know what is the group of speed group? It is speed regulation, like voltage regulation in alternator. Okay. I will start to explain here. So suppose there is a one alternator. Low communication हो गया इसमें. Okay. So this is alternator. It is connected to a bus bar load. बैटरी होती है क्या? Suppose here is a load is connected. Okay. This is in kilowatt, load in kilowatt. When we vary this load, okay, so there is a bus bar voltage and frequency. Okay. So when there is a no load on alternator. Okay, suppose this is the alternator connected to bus bar load and it is in load, suppose in kilowatt load. So at no load, this frequency, if you know, frequency is directly proportional to speed. Okay. So as put the load on alternator, it will slow down. You know, there is a prime mover is connected with this. It will run this alternator. We get electricity. Okay. So when we close this, so now if we plot the curve between frequency versus load or speed, because speed means it is frequency. So we take a variation in frequency. Okay. Here we take a load on alternator in kilowatt. Okay. So here this is okay. Now it is suppose 200 kilowatt, 400, 600, 800, 1000 kilowatt. It is full load rating. Okay. 200 kilowatt, 400, 600, 800, and 1000 kilowatt. Here, suppose when there is a 0 kilowatt load, then what is the frequency? That is called no load frequency, F naught. Let us it is 62 hertz or 52 hertz. Then as we put the load on alternator, its speed is reduced, means frequency of bus bar is drop. So at 200 kilowatt load, it will be like here. Then at 400, it is down like this. Okay. So actually, if we plot the curve, it comes like this. Okay. So this is the curve we get. Okay. Like at 200 kilowatt, 400 kilowatt, 600 kilowatt, 800 kilowatt, 1000 kilowatt. So at 1000 kilowatt, what is the frequency? F. And this is at no load frequency. So this variation, no load frequency minus full load with respect to no load frequency into 100. This is called your percentage speed regulation. Okay, or this is called droop, percentage droop. Is droop. Okay. Clear? Droop setting. Okay. This is called percentage drop. Clear? So it is a drop in frequency from no load to full load. If suppose we further we put the load, we increase the load, then it is your alternators will overload, and then bus bar frequencies drop again further here for this much of load. So here maybe it is up to 60 hertz. Here maybe it is 59.5 hertz. Further drop. Clear? Sometimes this question is asked at no load is set higher than the bus bar rated frequency. When suppose already there is some machines are connected to this bus bar, and this bus bar frequency is 60 hertz. Then when we connect this incoming alternator to this bus bar, then no load frequency is set higher than the bus bar, like 62 hertz. Why? Because as we connect the alternator to bus bar, it take the load, the frequencies drop. Then at least this bus bar frequency should be within this 60 hertz. Suppose you no load frequency you set 60 hertz. Then when it take the load, its frequency is further decreased. Then overall frequency of bus bar is decreased. So to maintain the constant bus bar frequency, the no load frequency is taken slightly higher than the bus bar frequency. Okay. Now this is the speed or speed droop, or it is called frequency versus load curve. Why we call it frequency versus load curve. This curve is called frequency versus load curve. Okay. Next, now this play the important role when two machines are connected in series. Okay, so now consider two machines identical, alternator or machine are connected in parallel and sharing the load, sharing a load combinedly, jointly. Okay. Now let us say there is a two machines, machine 1, machine 2, same capacity. They are running in parallel. Okay, they are connected to parallel bus and they share a common load, this total load. So if they're identical, then they have a same droop setting. If percentage droop setting are equal, okay, then alternator 1, alternator 2, this for machine A, machine B, or you can say machine A, alternator B. Okay, they share this load. See, so there was one question they asked. Explain the significance of speed droop during parallel operation. So it play the important role during parallel operation. Assume two alternators running in parallel and draw the frequency versus load curve. Okay, with load sharing. So you draw this curve, then draw this diagram and draw the curve also. So now frequency is a frequency versus load curve. Okay, so let us there is a this one. On same graph paper we can draw the curve of both machines. Okay, see here we can, this is suppose your total load, this is your kilowatt load, total kilowatt load. Okay, now here this is the frequency at this axis, here is the load. Now for machine A, suppose there is no load, frequency are equal. Okay, their F0 are equal, suppose. Okay, now then they share the equally this load. Okay, the equal point, and means their speed versus load curve, they intersect this line like this. Okay, so this will be operating point. Okay, means, and what is the frequency? This is your frequency, operating frequency. This is your full load frequency, this is no load frequency, and they share the load equally at this point, operating point. So this is here, this is kilowatt A, load on alternator. This is kilowatt B. Okay, means this curve is represent the machine B and this curve represents the machine A. Okay, now suppose droop setting of machine 1 A, we increase means, so this line slope, this curve slope is increased if you increase the droop setting. So means this curve is shift now. इसको पूरा इधर आप ठीक है ना. Now see, if If we increase the droop setting of A, this line slope characteristics is down. Now I like this. Now this operating point is shift here now. They intersect each curves here. See now this is the load curve of A. B as it is, but curve A is down. If we increase the droop setting of A. Then see now this operating point here. So what is the kilowatt load? Kilowatt load A is this much and kilowatt load is on B. Kilowatt B. B now this. So now load on machine A is decrease and this machine B will overload. It means your this droop setting, droop curve is play the important role on load sharing. Now this curve, okay, we can other simplification we can do. See this F frequency we take a common for both machine. If we frequency we take a common for both. Now this is the load. Okay. Yeah. Your machine B is 800 kilowatt, B is 200 kilowatt. Okay. So actually this portion we represent, this is the frequency. Okay. This is frequency. Now this is the full load kilowatt of, this is 1000 kilowatt rating of machine. This is the rating of B machine. It is 800 kilowatt. That is, it is B rating. Yeah? So if, and this is suppose no load frequency, F naught. Okay. Now, then what is the load frequency versus load curve of machine B individual? This. And for B, it is this. Okay. They are individually. When there is a full load on B, then this is the curve. So, okay. And this is for B. This is machine A. This is for machine B. Okay. But it means total load is 18 kilowatt. They can share. Okay. Their full capacity is 1800 kilowatt jointly. Okay. They can share. But if total load is only 1000 kilowatt. So if total load is only 1000 kilowatt means it is somewhere here to this is the total load. Now only 1000 kilowatt. So from here to here it is 1000 kilowatt load. Okay, up to here. And let us this is the load on A. So let us machine A will share X kilowatt. Then B will be shared 1000 minus X kilowatt. Correct? 1000 minus X kilowatt. This B will share. Okay. So here this is it is 1000 minus X kilowatt. Then and here this is operating. Let us here frequency is F. Okay. Now we ask what is the kilowatt load on A and B if 1000 is the total load. Okay. So this numerical we do. Okay. Let us use Venn diagram. Hello. Like two three-phase alternator operating in parallel, 1000 kilowatt and 800 kilowatt. Okay. So please machine or alternator A, alternator B. Okay. What is their capacity? Capacity. Yeah? It is What is the capacity? This is 1000 kilowatt. This is 800 kilowatt. Then he said that the droop setting of each droop setting or speed droop. Okay. Now he says there is a droop setting is for each machine is 4% drop, 4% here also. Okay. Sometime it is different droop setting. Okay, but here it is same. Now, if the load shared by both machine is total load is 1000 only kilowatt. Then what is the load on A and B when they are operating in parallel? Okay. So calculate the load sharing if original. Now no load frequency is given. No load. What is the frequency at no load? 62 hertz. Okay. Then A2. Then what is the frequency drop? Then therefore frequency drop from no load to full load. So it is 4%. It is given in percentage. So actually it is 4% of what? No load frequency. And then percentage it is 0.4. No? 4% means 0.04. It's divided by 100. Okay. Correct. What is the drop? 4% of 62. Okay. So how much it comes? It is 2.48 hertz. So what is the full load drop? It means suppose no load frequency is 62 hertz here. Okay. 62 hertz. Then if they share a full capacity 1000 kilowatt, then what is the frequency here? It will be total this drop. Hello, from here to here, what this drop is 2.48 hertz. This is the drop from here to here. Then what is this? It is 62 minus 2.48. Then it comes 59.52 hertz. Okay. So for both it is same. Here also same drop for this. Okay. That's why they are this. Now, right? If both machines are connected or operating connected in parallel and sharing a total load of 1000 kilowatt. Let X is the kilowatt load on machine A. On machine A. Then 1000 minus X will be kilowatt load on machine B. And F is the operating frequency. Okay. If total load is if here total load is 1800 kilowatt, no, then they operate full capacity both machine, and the operating frequency will be 59. What is the frequency? 59.52. but now load is only 1000 kilowatt. Now if load is only 1000 kilowatt, then he asks what is the kilowatt load here, and maybe frequency. Here frequency is not asked, but sometimes they ask. Okay, so very simple. You make this diagram, and very simple. Hello, you see this curve is for A and this for B. So there is a two triangle. If you observe, there is a two triangles. They have a common angle C. First is bigger outer triangle, this. Second is small, this triangle, this. There is a two triangles now. One is outer, other is inner, small. They have a common this angle here, na, this angle. So if this triangle, their side and height ratio, like this is x, this is 1000 base, and height. What is this height? This we can write na 62 minus f here to here. And what is this height? This height is 2.48. Clear? Same like for B. Okay. So now we can write for alternator or machine A. Here write for alternator B. Okay. So please, like a ratio is from small triangle to big triangle, you can write. Okay. So like base of A equals to, base of small triangle to their base ratio and height ratio are equal. Like base ratio. Hello.
Excuse me, sir.
Yeah.
सर ये 62 माइनस एफ वाला जो रेशियो है वो बड़ा रहेगा ना सर? 2.48 वाला कैसे बड़ा रहेगा?
बड़ा ब्रदर, यहाँ पर ऑपरेटिंग फ्रीक्वेंसी आएगी वो
नहीं सर आपने जो दूसरा जो ट्रायंगल बनाया सर, वो उसमें 62 माइनस एफ जो है वो अपना 59 पॉइंट समथिंग आ रहा है सर, 59.5।
वो यहाँ पे फ्रीक्वेंसी आ रही है। हमको ये डिफरेंस चाहिए इनका हाइट का। ये डिफरेंस मैंने लिखा ना यहाँ से यहाँ तक। जब व्हाट इज दिस बट हियर टू हियर इज, वो इससे कम ही रहेगा ना। देखिए सी what here this is the frequency here, but here is higher than this, इससे ज्यादा ही रहेगी। here maybe it is 61 hertz or 60 hertz here। ओके देखिए इस लूप में आप जिस तरह नीचे आएंगे ना, इस कर्व में नीचे आएंगे तो फ्रीक्वेंसी डाउन होती जाएगी। ओके इफ यू गो अप इट विल इंक्रीज। तो नो लोड इज 62। अभी देखिए अगर आप अल्टरनेटरों पे और लोड बढ़ाते जाए, सपोज 2000 किलोवाट डाल दें टोटल लोड, तो ये दोनों अल्टरनेटर क्या होंगे? ओवरलोड होंगे और ये यहाँ पर शेयर करेंगे लोड। तो व्हाट इज द फ्रीक्वेंसी हियर? दैट विल बी मे बी 59 हर्ट्ज। तो इससे तो कम होगी जो यहाँ पर फ्रीक्वेंसी। द फ्रीक्वेंसी एट
तो मुझे ये डाउट था कि जो एफ नॉट माइनस एफ है वो 2.48 आएगा ना सर?
हाँ यस, यहाँ पर जो एफ था उसको हमने 62 माइनस एफ किया, दैट विल गेट दिस। बट ये जो डिफरेंस है ना 62 माइनस दिस, सॉरी ड्रॉप, ये मैंने रॉन्ग लिखा है। यू आर राइट, ये मैंने रॉन्ग लिख दिया यहाँ पर, इसलिए आप कंफ्यूज हो रहे हैं। एक्चुअली व्हाट इज द फ्रीक्वेंसी हियर? हियर फ्रीक्वेंसी इज 59.52 ना। this is the frequency here, then this minus this is this, okay, 2.8. okay, now clear? okay, so basically this height in hertz, it is this. What is the frequency here? After you subtract this drop from 62, means this will, how we get, ये कैसा है वैल्यू? 62 minus 2.48. Then you get this value. Okay.
सर मतलब ये जो F0 और F जो है सर, जो वर्टिकल लाइन है वो 2.48 होगा ना सर, उसका डिफरेंस F0 और F का?
यस यस,
जो मिडिल वाला F है और ऊपर वाला F0 है सर।
हाँ, बट दिस डिफरेंस हियर टू हियर इज डिफरेंट एंड हियर टू हियर इज डिफरेंट. यहाँ पर हमें पता है जब व्हेन इट इज फुल लोड इट विल बी दिस मच हर्ट्ज, but let us here we not know what is the frequency. Let us be consider F. Then this drop will be 62 minus F. Okay, clear?
गॉट इट सर, थैंक यू।
And ये वाला जो हमने कैलकुलेट किया है ना, ये कहाँ से आया? We have calculated like this. Percentage drop means what? 4%. 4% means 4 divided by 100 equals to what is that? F0 minus F by F0. ये F0 इससे मल्टीपल हो गया, तो व्हाट इज द F0 by F इक्वल्स टू 0.04 into 62 F0. So this is we calculate na, this is the frequency of this, sorry, this drop we calculate. Then this frequency is this minus drop, so we get this bus bar frequency at full load. Okay, clear? This speed frequency drop we calculate from no load to full load.
क्लियर सर, थैंक यू।
Now come to next. But so there now this triangle height base ratio and height ratio is small to, we are writing small base small to big triangle base ratio, small to big triangle height ratio. So this height was for bigger is this. Same for B, alternator B. Like what is the small triangle base? It is 1000 minus x by 800. ये कहाँ से मिला? देखो इधर, what is this base? 1000 minus x and this is 800. Because they have a same group setting, it means this side is same. Okay, sometime it is different. Okay, so this is, you can say this is equation 1, this is equation 2. Now you know their left hand side are equal. 62. So from equation 1 and 2, so we equate na this x by 1000 equals to 1000 minus x by 800. शायद ये दो जीरो से जो जीरो कैंसिल हो जाएंगे, so you get a x by 10 equals to 1000 minus x by 8. Now cross multiple. By cross multiple you get 8x equals to 10. Now this become a 10,000 minus 10x. Okay, clear? Then it become 18x equals to 10,000 or x equals to 10,000 by 18. What is the value of x? 5555556 kilowatt. Then what is the load on B? This is the load on A. Load on B machine is 1000 minus x. So you write 1000 minus 555.5. Triple 444.44 kilowatt. Okay, so if you add na this both, you get 1000 kilowatt total. So okay, now you can say what is the load on A and B. You can tell this. If they ask na frequency, here it is in this question they not ask, but they can ask what will be the frequency, system frequency क्या होगी. Then in any equation, either 1 or 2, you substitute the value of x. So by substituting the value of x here, you can calculate from this, either from this. Okay, that f is your actual operating frequency at this load. Okay, clear? It is earlier in ETO this question was asked. Okay, in question answer set na.
सर इनकेस अगर ड्रूप का वैल्यू दोनों का डिफरेंट रहता तो भी सेम लगा सकते क्या सर ट्रायंगल से.
Time ही लगेगा वो. Okay, I will tell you, show you one another numerical. It is in set of this है ना question answer set. वहाँ पर है एक क्वेश्चन, वो मैं आपको बता देता हूँ जल्दी से. इसके बाद हम वो एम्पलीफायर वाला क्वेश्चन बताएंगे, बट वो अभी तक दोबारा रिपीट हुआ नहीं है. फिर भी ओके, वी विल टेल यू. सेट में है एक क्वेश्चन लास्ट में इस तरह का. I will show you. Here is a load sharing question. It is easy by वही same है, tan phi and this thing, load sharing. Now load sharing is asked either by the power triangle base or with speed group. Okay. So the power triangle you calculate active reactive power. Clear? Or otherwise this load method है. Speed group का है. देखो ये क्वेश्चन आता है यहाँ पर, ये रॉन्ग किया हुआ है इधर ये सॉल्यूशन में. ओके, ये 666.54 आएगा वो. यहाँ पर ये रॉन्ग है सॉल्यूशन. ओके, यू डू इट करेक्टली. ओके, जैसा हमने कराया था. ओके, और यहाँ पर ये सही क्या है, इसका पावर फैक्टर क्या रहा है. देखो इन्होंने यहाँ दोबारा इसको ठीक किया है. ओके, प्लीज डू यूज दिस. This question is also important है. स्टेज हाई वोल्टेज सिस्टम. वो दो क्वेश्चन आ गए. Electrical propulsion and emergency source of power. Please you prepared that. And polarization index R10 by Rn. It is available in group. Okay, you read this question.
Sir, this PDF we have in the group?
Yeah, yes, it is available. Question
Okay.
answer, you can search, PDF file is there.
Okay,
This
sir.
question load sharing is also like same power triangle base. Okay, these are easy all questions, you can try it. ये बैंक है. Yes, this question है. It it has a different droop setting. See, you should not confuse. That's why I want to here. आप ये सिंपल वाला डायग्राम बना के एक्सप्लेन कर सकते हैं क्या? Here 2DG set है. 2DG set means diesel generator means alternator. Okay. So he said that there is a 2DG1, DG2. DG2. They are operating in parallel. And this having a capacity, their capacity is given. It has a 2000 kilowatt. Both are generator having this color. Two generator are running in parallel with generator are having 1000 capacity and with 3% droop setting. Droop percentage droop is 3%. It also has a 2000 kilowatt capacity, but their droop setting is 4%. 4% is speed droop or droop percentage droop. Okay. Now we say that the frequency of these are at no load frequency, no load 62 hertz. Calculate the load on generator A. Sorry, on each generator. If total load is here, total load is given 1000 kilowatt only. So actually they here total load, we have a capacity total 2000 to 4000 kilowatt. But here actual load is only 1000 kilowatt. Then we ask what is the load on each machine and why it is difference in sharing. Actually, if both have a same rating capacity, they are equally share this load. But because they have a different droop setting, their load sharing is different. Clear, na? If you connect two alternators of same capacity, they share the load equally. But because due to different in droop setting, so you can write your load sharing is inversely proportional to the droop percentage droop setting. Okay. So see, higher the droop setting, lower will be the kilowatt load. Let us be check here na. If this is load droop means it share a more kilowatt DG1. Okay. So again we can draw the diagram na, this load curve. So here percentage drop here, frequency drop at full capacity. Then what is the item? It is 3% means 0.03 of 62 hertz. Here it is 0.04 of 62. It comes 2.48, but here it comes 1.86. Okay, drop. So see here. This is your frequency line, speed or frequency. Now their base, now see, they have a equal kilowatt, means their line should be equal, load to, this is 2000 kilowatt, this is also 2000 kilowatt. Okay. So their base equal. Now if no load frequency is this 62 hertz, F naught. So when they are individually operate and at full capacity, this is the curve. Same for machine DG2 also. This is DG1, this is DG2. Okay. Now, sorry, but their group setting are different. Which as well as 1. Means this line will be offset. Here only 3% drop. Here it is 4% up to here only. ये थोड़ा गलत हो गया हमारा. ये offset होंगे. Why? Hello? Why they are offset? Tell me. Because here it is this height. This height is, hello? What is this height? It is 1.86 hertz only. But what is this height? Here to here, this drop. Please. This is 2.48 hertz. Correct, no? Here means alternator 1 0 to up to full load. What is the drop? This drop. Okay. Is 1.86. And this drop here to here, machine generator 2 is due to drop setting, it is a 4%, means it is 2.86 hertz. Okay. But now
So
if they are
2.48.
2.48, sorry. 48. Now, but let actually what now? Here, now if both machines are operating in parallel and total load is 1000 only, तो 1000 लोड के लिए कर्व कहाँ होगा? यहाँ पर भी नहीं होगा ये बिटवीन. अगर 3000 किलोवाट होता ना, 3000 किलोवाट, then it is operating here between these two. If it is greater than 5000 kilowatt, then it is curve will come beyond this point also. ये यहाँ पर होता तब कभी. Okay, then both machine will be overload. Okay, clear? But our load is only 1000 kilowatt. It means where it operate above here, na, it is very less, means 1000 it is this much only. Okay, so means this is your let us it is operate. No arrow nahi lagana. Means this is the suppose here it is operating here, this is, okay, and let it point as a F frequency. Okay, then X load is on the machine generator, and what is the load on B? This height, this length. We are confusion mat hona hai, please. There is this. It is this height. This is, what is the load on here? This is 1000 minus X, no, kilowatt. So now please DG1, DG2. Okay. So for DG1, it is X by, hello, this is also 2000 kilowatt. This is also 2000 year to year. So it is X by 2000, sorry, equals to their height ratio is 1.86. No, sorry, small to bigger, no? Then what is the 62 minus F by 1.86? Here it is for alternator 2, it is 1000 minus X by 2000 equals to 62 minus F by 2.48. So now these are different, no? So now you cross multiple. इनको हम यहाँ से ना इसको आगे भी बढ़ा के सॉल्व कर सकते थे वो इक्वेशन को किस तरह से पता है? You cross multiple, then you get a two equation in x and f, okay, variable. Then you solve that simultaneous equation, you get a x and y f value. Same here. If you now we cross multiple na this, so it comes 1.86 x equals to 2000 into 62 minus f. This is one number. Same here. 2.48 into 1000 minus x equals to 62 f into 2000. अगेन यहीं पर हमको सॉल्यूशन भी मिल गया. देखो ये दोनों ना लेफ्ट हैंड साइड दिस एंड दिस आर इक्वल. ओके, दोनों इक्वल है. इट मीन्स फ्रॉम इक्वेशन 1 and 2 you can write now 1.86x equals to 2480 minus 2.48x. Okay, then you take it 1.86 plus 2.48 x equals to 2480. Then x equals to 2480 by how much it is? 1.86 plus 2.8. It is 4.34. Then 2480. You get a 571.43 kilowatt. Okay, and what is the load on? This is the load on TG1. Therefore, and load on TG2 equals to 1000 minus x value is 571.3. Please, it is 428.57 kilowatt. Okay, so this is, if they ask na frequency, now x value you put in this equation or either this, you get a f also. So see here, both machine have a same capacity, but due to different group capacity, load on generator is 571 and load on generator 2 is 428. So which share the more kilowatt? Machine hai, which has a less group setting. Okay, clear?
Sir, for that question, the B part, we have to just justify the answers, right?
So you just write na, because generator 1 has a less group setting na. Okay, and your speed group is means load sharing is inversely proportional to speed group. It is written na here, justification.
Okay, sir.
We have right na here inversely proportional initially in this question. See? Here, this is the justification. Okay. Now I want to give one exercise because tomorrow is only left now. So today night you solve, yeah, tomorrow you can practice. I give some one practice question. Okay, practice. ये ऐसा मत सोच के बैठ जाने कि यही क्वेश्चन आएंगे. ओके, इट इज जस्ट फॉर योर प्रैक्टिस. ओके, इतना उसमें एफर्ट नहीं डाला है हमने. ओके, वी हैव प्रिपेयर्ड expected questions. Okay, so it is for ये प्रैक्टिस कीजिए. Now we come to one. In which month that amplifier question was there? But hello, in which month this question was there? एम्पलीफायर जो गेन वाला था क्वेश्चन. Any have idea? Someone is asked.
सर वो ग्रुप में पोस्ट किया था सर.
किस महीने का हम यहाँ ओपन कर सकते हैं? वो ग्रुप में भी तो ऊपर रहेगा भी. Yes, no? Yes, so it hold. Yes, ये total power. 10 का है क्या? See, in September it was there, this alternator question जो मैंने बताया था आप लोगों को. Okay, this percentage.
Excuse me, sir.
Which year is which month actually? जो भी रहेगा ठीक है. Okay. So you know actually transistor amplifier. Okay, there is a two types of transistor, PNP, NPN. So generally we prefer NPN and common emitter configuration. Okay, transistor amplifier stage comprises of a transistor of a parameter. So now that circuit is converted into hybrid parameters. Okay, configuration. So we not go in that much, otherwise there is a lot of equation and derivation directly I can know. Just I briefly explain. Okay, so we write NPN, C common emitter transistor amplifier. So if we make the circuit na common emitter, this is your transistor. NPN, it has a symbol here, emitter. This emitter is common here. Now this is the base. So there is a biasing resistance in series. Okay. Then we have a here source. Okay. And there is a now here is another. This is the signal which need to amplify. Okay. Supply voltage source. Then here we apply the base voltage. This is the base, no? It is called base voltage. Okay. Then this is emitter current IE. Then it go to this. Here this is the load. Across this load resistance. Across this we get a amplified signal. Then emitter voltage we also as a bias. Again here we apply the voltage potential. This is V collector current. Okay, collector applied voltage. This is base voltage. This is collector voltage. Load resistance. Okay. So here load current is flowing in this. Suppose this is the load current IL. So actually this collector current is in opposite direction IC. We can say IL equals to minus IC. Okay, load current in opposite direction. This is emitter current. This is series resistance in the bias. Okay. This configuration. Now for analysis purpose, this convert into hybrid network, two-port network in hybrid. Okay. So here this is your series resistance, then this is the input signal. Okay. Then we have here this input resistance, hybrid input parameter. Here we see this is your base voltage signal. This is called as a input hybrid parameter. Then here is a voltage source. What is the it is ZE. Oh sorry, RE. Hybrid parameter. Okay. HRE. Okay. Then This is voltage source. Here is a current source. Current source. What is the parameter? It is called HFE. Then here it is a load. This has a parameter 1 by HOE. And here your VC, collector voltage. Okay. Then you have a load resistance RL. Across this we get a output. Okay. So this is the two-port H parameter, two-port network with H parameter. Okay. Using H parameter. Okay. So here we write the parameters here given. Now I write what is the current, बाद में लिखूंगा पहले इसमें क्या क्या पैरामीटर दिए हैं. H parameters है, hybrid parameter or H parameter. So when we solve it, what is the H parameters dimension given है, H parameters which are given. Okay. HFE is given. The first H input parameter, hybrid parameter is 800 ohm. HE parameter is 50, it is unit less. And HOE is your conduction, it is opposite to current. Okay. It is 20 micro ohm. Sorry. Micro myo, opposite sign. It is conductance actually. Conductance. Unit of conductance. So we can convert into 20 into 10 raised to power minus 6. It means that much of. Now H reference R is not given. Now input signal. Input voltage signal. Voltage signal. That is 60 millivolt. Means 60 into 10 raised to power minus 3 volt is given. Source resistance. Source resistance RS is given 2.2 kilo ohm, or you can consider 2.2 into 10 raised to power 3 ohm. Then load resistance RL 40 kilo ohm, means 40 into 10 raised to power 3 ohm. Yeah, these are the given parameters from here.
Sir, it's 4 kilo ohm, right?
Further it is 4 kilo ohm. 4 kilo ohm. 4 into 3, 10 raised to power 3 ohm. Okay. Now I write what they are asking. So approximate formula for first they are asking what is the current gain. Current gain in terms of hybrid parameter AI. Then they are asking voltage gain. Okay, AV it is represented. Then power gain P. Power gain is you can easily calculate voltage by current, no? AP equals to AV into AI. Okay, you get a power gain. see this current gain equation is minus HFE by, you forget about derivation now, you please remember this much only, okay, into load resistance. So if you know this parameter, you put here, you get a current gain. Then voltage gain. So actually here HOE RL is less than 1. Okay, so we can neglect this. Okay, then if we neglect then AI is equals to minus FE only. So what is the FE? Hello? What is the FE? 50. So this gain answer is 50 only. Okay, gain is a ratio, so no unit. Okay, then voltage gain
minus 50, right?
Yes, minus 50. Now voltage gain is as sorry. Yes, in terms of current gain, it is current gain E into RL by Z I. What is the Z in it is HIE only, 800 ohm. It is given now. Now current gain we know. E is stand for common emitter configuration. Okay, so please do not confuse here. H parameter HFE means in common emitter configuration. E is instead for common emitter. Okay, if common base, common collector, then it is different. Okay, so here in this values are but parameter change. No, so it is current gain in common emitter means same value. Okay. कभी कंफ्यूज होंगे सर here it is no there is a E, actually it is come in common emitter voltage gain in common emitter like this. You can put E. Okay, please. It is in input impedance in common emitter, so this is hybrid. So here common emitter gain is 50, load resistance is 4000 divided by this is 8000. So this is cancel, it is 5. Then what is the value? 250. Okay. Now you calculate power gain. शायद नहीं क्वेश्चन में 40 आया था क्या इसमें? 4 ये 40 रहेगा तो वो भी वैल्यू चेंज हो जाएगा. Now please, what is the current gain? Voltage gain into current gain is 50. This much minus, because it is negative na 50, so it will be negative. Okay, this much only.
Sir, voltage also, AV also minus 250, right?
Yes, these are also negative. Okay, so it means negative means here what is the minus sign means what it show. Suppose here you apply this input signal is small input signal, correct? Small means it is this much is your input. So here it is amplified across this. Here we get output signal. It is amplified and it is inverted. Means you get a signal like this much. Okay. Amplitude is increased, but it's inverse also. Okay. Invert. Clear? Amplified signal. Okay.
Sir, if positive means just normal sine wave, right?
This, yes. Signal, what signal you apply here? So, small signal, it will increase. Na? In amplifier, what it do? It increase the amplitude. Okay? Apply the input signal, input. Okay? Then it amplify. Negative means it polarity is different. Okay? Opposite. Yes, sometime now one question is very different in nature. They ask. Okay. So like in this question paper also, if you go na, other questions are easy. You can attempt that question if new question they ask. Okay. Okay. So mostly we cover all. You practice some alternate sorry rectifier question also. Okay. Already rectifiers we cover in that first chapter along with. Okay. So best of luck. You be confident. Appear in exams. Okay. Definitely you get a good questions. Okay. Please. And you know you practice this question paper. Okay. Here emergency source, draw and explain the characteristics of PN junction diode in forward reverse bias. And what are the short circuit? How do we short develop in generator and external circuit? What is the result in case occurrence of short circuit in minimize? How we can we use secure the means their insulation level rated. Okay. Describe the measures taken to vary inputs when running a 60 Hz system on 50 Hz. A series circuit consists of a capacitor and a coil inductance, this and the resistance of this. Find the total impedance, leg or lead yours. Three-phase induction motor, power, frequency, losses and efficiency you have to find. What is the single phase? Simple single phase transformer, and you write this. This is the numerical. It is on regulation. Okay. Efficiency of transformer you calculate, and at half load and on full load and unity power factor. Then
The slide is not visible.
नो बंद कर दिया क्या शेयरिंग वाला? Okay.
Yes, sir.
So these are the questions you have to read. See this. Here I am reading this question. Transformer, single phase, primary resistance, reactance. Primary and secondary resistance are given. Here resistance है दोनों R1, R2. Okay. So you can iron losses are given kilowatt में. Now calculate the efficiency of transformer on full load unity power factor. Cos pi you take 1, and then copper loss we calculate. Iron losses are given 80% full load at a power. So actually it is not a regulation, it is only efficiency. You have to calculate a transformer efficiency, but at full load or at not half load, 80% load. Okay, 80% means what is the full load kilowatt? It 50 kVA into power factor is unity. Then what is the 80% means full load at 0.8, it is 50 kVA into 0.9, and 80% means you multiply with 0.8. Okay, then that is the output. And input के लिए क्या करेंगे? Output plus loss, then iron loss are same, but copper losses, what is the full load copper loss? So please you calculate equivalent circuit as referred to secondary side. So R2 plus R1 days. Okay, turn ratio you can calculate from this. Then current you calculate, full load current. Okay, so then I2 square RL. I2 square RL you can calculate. No? So you get a copper loss, full load, but at 80% it is square time of full load. So your 0.8 ka square time, your copper loss are vary. Okay. Actually, yeah, copper loss are square time of full load copper loss. Okay. So see, full load and partial load. Okay. So if load is full load, then what is the copper loss? Sorry, load लिखते हैं इधर. Okay. Load, if it is full load, then what is the copper loss? उस केस में आपके copper loss होंगे I2 square R02 full load. Okay, this much. Then at now if at this means ये जो copper loss होंगे from W full load copper loss लिखते हैं. Okay. Then what is the at 80% load of this means 0.8% of this load. 0.8 of full load, no? Of full load percentage. Full load means what is the full load? That here we use it with 15 kVA into your power factor. Okay. Then at actually percentage loading, square time of percentage. So we can calculate at 80% load, what is the copper loss? 0.8 square time of full load copper loss. Just you write this. Okay, full load copper loss. This will be the copper loss on at 80% load. Percentage load का square times होगा. Okay. Correct. Your copper loss will vary with the square times of percentage load. Then so we can calculate efficiency at full load and unity power factor and 80% and 0.9 power factor. You try these questions. Okay, just they are practice. तो जरूरी नहीं है यही आएगा. Okay, ऐसा नहीं है, ये आपको खाली प्रैक्टिस के लिए रखा है हमने. Okay. This is one electrical circuit question. Okay. Okay.